Yes, sir. Uh, so for me, chemistry is like uh, some other teacher is taking, yeah.
What you just said?
So for me, chemistry is taken by some other teacher, Salim
Okay,
sir, I think.
okay, got it.
Yeah.
So, how many chapters you have?
So we have covered 3 chapters.
First, second, third.
Yes, sir. Uh, Second,
So,
then we went to haloalkanes and haloarenes. Now we are on alcohols, phenols, and ethers.
are you in class 12th?
Yeah, yeah.
This is for class 11. This
Uh,
batch.
so I
I
don't
think
know. Uh,
who
let me
gave
let
you
me check.
the ID?
Um, I got the link for biology. Uh,
Biology. This
yeah.
maybe there is a mistake. Please. Uh,
Okay, let me continue.
okay. Arnav, are you there?
Yes, sir.
Okay. Arnav, so today we are going to basically in the previous class we have seen about Rutherford and Thomson's model, right?
Yes, sir.
Now we are going to start electromagnetic radiation. See, what is electromagnetic radiation? So I'm going to define it. It is very easy, and I have already covered this part but didn't define it. So please write with me. The wave that generates electric field and magnetic field. Electric field and magnetic field during their propagation is called electromagnetic waves, and they are perpendicular to each other. We can write they are perpendicular. They are perpendicular to each other. So basically, if you have a question, what is electromagnetic waves? The wave which generates electric field and magnetic field during their propagation is called electromagnetic radiation, and they are perpendicular to each other, or we can define it other way also. In other words, like the wave which propagates causes oscillation causes oscillation of electric field and magnetic field. Electric and magnetic field. Do you know what is oscillation? Magnetic field, which are perpendicular to each other, which are perpendicular to each other. Are you there? Perpendicular to each other, as well as direction of electromagnetic waves. Arnav, are you there?
Yes, sir.
So see, this is the definition in other words, like the wave which propagates causes oscillation of electric and magnetic field which are perpendicular to each other and also perpendicular to the direction of electromagnetic wave. Is right. Let me know when you are done with this. Done. Or no, you are not audible.
Done, sir.
Thank you. Now see, we are going to see what is the characteristics of electromagnetic waves. Before that, I'll draw this. Just suppose this is y-axis, this is x-axis, and this is z-axis. So you know that this x-axis, y-axis, if shows electric field, then this is magnetic field, and this is direction of waves. So this is how electric field, magnetic field, and direction of waves connect to each other. They are perpendicular to each other. Okay. Characteristics of electromagnetic waves. When we talk about characteristics of electromagnetic waves, just write the points I'm writing. They do not require any medium. They do not require any medium for their propagation. For their propagation, like sound. Sound requires medium to travel, but light does not require any medium to travel. If you are going to speak in vacuum, there will be no sound of your voice. It is visible and visible. It is visible as well as invisible. That depends on its wavelength. Next point we can write. They do not have charge. They do not have charge. Next point. The velocity of electromagnetic wave is independent of source and in vacuum its speed is or its velocity is 3 into 10 raised to the power 8 meter per second. That means the speed of light will be equal to the speed of light in vacuum. So very easy it is.
Done, sir.
Very good. Wait a minute. Wait a minute, please. Now see, this electromagnetic waves, like I'm going to give you some example of it. X-rays, gamma rays, ultraviolet rays, microwaves, radio waves, which are invisible. Which are invisible. There are microwaves. Vibgyor, that is visible, and then infrared. These are all example of electromagnetic waves. Okay.
Okay, sir.
Remember one more thing is that we have already covered the characteristics like wavelength, amplitude, wave number. We have covered now.
Yes, sir.
Yes. Are you done with this?
Yes, sir.
Now see, these waves or this electromagnetic radiation, how to remember this in increasing or decreasing order of their wavelength or frequency. As you know that nu, that means frequency is equal to c by lambda. I had taught this in previous lectures, that nu is inversely proportional to lambda. That means if any wavelength which has maximum wavelength, that means that will have minimum frequency. Yes or no?
Yes, sir.
Now see, you need to learn it from this sentence. College girls are ultimate visitors in my restaurant. Now see, this C for cosmic rays, G for gamma rays, and since I don't have any restaurant, so I'm going to cut it. So this will have X-rays, U for UV rays, V for visible, I for infrared rays, M for microwaves, R for radio waves. Radio waves. Now see, if you are going from left to right, if you are going from left to right, lambda increases, that means frequency decreases. Sometimes questions will be asked by in the questions it will be given the electromagnetic waves names will be given, and it will be asked that write it in increasing order of wavelength or frequency. So we can easily learn through this sentence, which is very easy. Visible is the one we can see with our naked eye, and it has this much 400 nanometer to 750 nanometer wavelength. Let me know when you're done with this.
Done, sir.
Very good. Now we are going to start a new topic, that is Planck quantum theory. Planck's quantum theory. So see, what is Planck's quantum theory? And before that, I'm going to introduce a new term, that is quanta. That is quanta. So I'm going to write light travels. Light travels in the form of a small packet of energy, a small packet of energy called quant, called quantum, and quanta is basically plural form of this. So according to Planck's quantum theory, since light travel in the form of a small packet of energy, and if the light strikes any metal or any surface, it will energize that metal surface, yes or no? It will energize, it will give some energy
Yes, sir.
in the form of
Yes, sir.
quanta to that metal surface. So this energy is basically directly proportional to the frequency with which it is incident on any surface. Now see, E is directly proportional to nu, and to remove this proportionality sign, we are going to introduce a proportionality constant, that is H. That is H. So E is equal to H nu. E is equal to H nu. H is Planck's quantum, Planck's constant. H is Planck's constant. which has a value 6.634 into 10 raised to the power 6.626 into 10 raised to the power minus 34 joule second. Also, it is important to note that this energy for only on one photon or quanta. Photon is also the small packets of energy. Now, see, if we are going to write NH nu, it's also good. N is the number of photon. N is number of photon. And you also know that nu is equal to C by lambda. We know that nu is equal to C by lambda. So E will be equal to Hc upon lambda if you are going to modify it, or either you can write it NHc upon lambda. And that means number of photons. Okay.
Yes, sir.
Please write it. One, are you done with this?
Just a minute, sir. Yes, sir.
One thing you have to remember is that electron volt, EV. This is electron volt, which is unit of energy. Unit of energy. And it is very small unit of energy. 1 electron volt is equal to 1.6 into 10 raised to the power minus 19 joule. Okay, so please keep it in mind. And other things like 1 angstrom, I have already told you about this, right?
Yes, sir.
Angstrom, nanometer, and all that. There will be shortcut formula too, direct in angstrom and nanometer. I'm going to write. Please write this and let me know.
Done, sir.
Now see, if you have nanometer directly, so lambda, if lambda in angstrom, lambda in angstrom, so E we can directly write 12,400 upon lambda in angstrom. Upon lambda in angstrom.
So what
Also,
is
unit
lambda in angstrom?
if lambda, this lambda, do you know what is lambda wavelength?
Yes, sir.
There is a formula for E. Na? E is equal to H nu E is equal to hc upon lambda. So
Yes, yes.
when lambda is in angstrom, we can directly apply this formula instead of hc upon lambda. And if lambda in nanometer, we can directly apply 1240 upon lambda. Okay, yes or no? And basically
Yes.
this will be in electron volt. The energy will come into electron volt, and you can easily convert this electron volt into joule. Please.
Yeah, done. Sir.
Yes, what you just said.
Done. Sir.
No, wait a minute. Wait a minute. Okay. Lambda is in angstrom. Okay, electron volt in energy in electron volt. That's good. I'm going to give you a question. Wait a minute. I'm going to give you a question. Calculate energy of 1 mole of photon which have wavelength 3000 Hz. Please do this question.
Sir, in joule or in electron volt?
You have to calculate it in joule.
Okay.
Will you be able to
So,
solve it or not?
66.1 into 10 to the power minus 20 joules.
66.1
1.
into 10 raised to the power minus 20 joule.
Yes, sir.
Now see, you have applied the formula E is equal to hc upon lambda. Since lambda is given, that's why we are just applying. We are applying this formula. Lambda is equal to 3000 angstrom. So you can easily convert this into meter if you are going to multiply it by 10 raised to the power minus 10. which
So we
means
can't
3
use that formula. If lambda is in Armstrong, then we can use E is equal to one
okay, E is equal to,
12,400
yes,
lambda.
you can use that 12,400 upon lambda as 3,000, but this energy will be in electron volt. Yes or no?
That's easy to convert, right?
Yes. After this, you can easily convert energy. You know where you did mistake, where you have mistaken. We are talking about 1 mole of photon, and you have only calculated for 1 photon. So after this, you are going to multiply it by 1.6 into 10 raised to the power minus 19 joule. This is for 1 photon. Yes or no?
Yes, sir.
And please use this formula in competitive exams, not in school. That's why I was doing this. This is shortcut enough.
Okay, sir.
And this is for 1 photon. And if you are going for energy of 1 mole, energy of 1 mole photon, then what you need to do is 124 upon 30 into 1.6 into 10 raised to the power minus 19 into 6.022 into 10 raised to the power 23 joule per mole, not per mole. It is total. 1 mole, yes, per mole it will be. Okay. So you can easily
Yes,
get
sir.
your answer. Are you done with this?
Yes, sir.
Okay, going to give you another question. Write a question.
So just in this case, how could you have solved with the previous formula, the one you were writing, E is equal to hc by lambda?
Okay, I'm going to explain. If you are going for E is equal to hc upon lambda, you can see this is for 1 photon, but we need to calculate for 1 mole photon. So first of all, I'm going to calculate for 1 photon. So lambda is equal to 3000 angstrom. So it will be this much meter, yes or no?
Yes,
Can I
sir.
write this? This will be this meter. Now see, E
Yes,
is
sir.
equal to H. Value of H is 6.6 into 10 raised to the power minus 34 into 3 into 10 raised to the power 8 upon lambda has a value 3 into 10 raised to the power minus 7. Again, you can see this is negative in denominator. When it will go in numerator, it will be positive, and 3 into just 3.6.3618 19.8 into 10 raised to the power minus 34 into 10 raised to the power 15. Can I write? Yes or
Sir,
no?
the three will get cancelled.
Yes, yes. I haven't seen that clearly. So you can see this will be cancelled 6.6. So you can see 6.6 into 10 raised to the power minus 19 joule. Yes or no?
Yes, sir.
Is it correct now? Energy for 1 mole. 1 mole. So you can see 6.6 into 10 raised to the power minus 19 into 6.022 into 10 raised to the power 23. So you can multiply and your answer will be in joule. Let me know when you're done with this.
Done.
Very good. Now going for the next question. You can see 100-watt bulb emits radiation Did I take a test in the last class?
Yes, sir, you did. Small test, I think.
Yeah, yeah. Wavelength 400 nanometer. Calculate the number of photons emitted by the bulb per second. We need to calculate the number of photons. Can you do this?
I'll try.
Okay. Power is given. So from power, we can easily calculate energy, total energy. See, I'm going to explain. Or no?
Sir, I'm doing.
Since you, yes, any answer?
I'm doing, sir. Almost done.
Okay, okay. I'm waiting for your answer.
No, sir.
Yes, any
It is
answer?
72 into 10 to the power 25.
No, no. See, 100-watt bulb. So basically, power will be equal to 100 watt. What is what? It is basically 100 joule per second. Yes or no? Power has a formula, energy per unit time, and it is, we can write 100 joule per second, and joule per second is called What? Yes or no?
Yes.
So energy we can easily calculate. Power is 100 joule per second, and time is 1 second. Since we are talking about per second, so second and second will be cancelled, and energy total is 100 joule. Now we have a formula: E is equal to hc upon lambda. E is 100 joule and hc upon lambda, because we need to calculate the number of photons. So nh has a value 6.6 into 10 raised to the power minus 34, into c has a value 3 into 10 raised to the power 8, and lambda has a value 400 into 4 into 10 raised to the power minus 7. Can I directly write it? Enough. 400
Yes.
nanometer, that means 400 into 10 raised to the power minus 9. So we can also
Yes.
write
Yes.
4 into 10 raised to the power minus 7. So you just need to calculate the value, and 100 into 4 into 10 raised to the power minus 7 upon 6.6 into 10 raised to the power minus 34 into 3 into 10 raised to the power 8. Yes or no? Now you can all easily calculate this. It will be almost, I'm going to tell you, 2 into 10 raised to the power 21 something. The answer will be like this. Let me know when you are done with this.
Yes.
Calculate the number of photons emitted in 10 hours by 60-watt bulb having wavelength 4,000 times. Can you do this?
Yes, sir. Just a minute.
What is the answer you got?
So 43.63 into 10 to the power 23.
Very good. Very good. This is the correct answer. So Arnav, in the next class, I'm going to take a test. And is there any doubt that you have?
No, sir.
No doubt. Okay. So basically, keep it in mind. There will be test every week. There will be test. Whether I will tell you or not, but every week, or it is 15 minutes or 20 to 15 minutes.